Hi everyone, today I'll discuss the dot product and why the dot product of the two vectors in any coordinate system will remain the same. The value of dot product does not vary from one frame to another frame, it's a kind of invariant. So suppose if we take any vector A, the length of this vector will be the same in any system. Let me explain it a little further. If you're going in a bus or train and you measure the length of the pen that you used to write, you find the length is same irrespective of whether the bus is moving or not. Now I'm taking another vector B. The length of this vector or the square of the length of this vector will be the same in any coordinate system, right? The square of the length of the resultant of these two vectors will not change if we change the coordinate system. Now if we look at each term, we get that these two terms are the same in every coordinate system. This term has popped up here and is a little bit interesting. We know these terms are the same in each system, so this quantity will have to remain the same whatever the frame we choose. This we call it as a scalar product of the vectors A and B. Now we know that the dot product of the two vectors is independent of whatever the coordinate system we choose. There is a geometrical way to calculate the dot product of the two vectors. It is the product of the length of the two vectors and the cosine of angle between them. But why? Suppose if we choose a special coordinate system in which the x-axis lies along the vector A, then the dot product reduces to this. And this is the length of the vector A times the component of vector B in direction of A, that is B cos theta. So this is another clever way to get the dot product of the two vectors in terms of the length of each vectors. Now we will discuss about the cross product. The cross product of the two vectors A and B, and it is denoted by A cross B, is itself a vector. It is the product of the length of the vector A and the vector B times the sine of angle between them. Here n cap is the unit vector in the direction perpendicular to the vector A and vector V. The direction of cross product can be determined by the right hand thumb rule. Place your stretched right palm perpendicular to the plane of vector A and B in such a way that the fingers are along the vector A, and when the fingers are closed, they go toward the vector B. The direction of thumbs gives the direction of n cap. If we know the component of the vectors along the coordinate axis, we can define the cross product of the two vectors as this. It has three components. Pause and ponder. What do these components represent in terms of area? The x component represents projection of area on a yz plane, and the y component represents the projection of area on the xz plane. And similarly, the z components represent the projection of area on a xy plane. Thanks for watching.